So we're finally to the fourth order Runge-Kutta method, and the fourth order Runge-Kutta method is the one that that is really commonly used, and so this is the classical form because, like the other methods that we already talked to, the second order method and third order method, there are an infinite number of possible fourth order Runge-Kutta methods depending on what we choose for these values, but the ones that we choose for the classical fourth order Runge-Kutta method look like this. So yi plus 1 is equal to yi plus 1 6 k1 plus 2k2 plus 2k3 plus k4 times h. So again, this is our integral estimate. 1 6 k1 plus 2k2 plus 2k3 plus k4 times h. And again, k1 is f of xi yi, k2 is f of xi plus 1/2 h. So what we see here, and then k3 also, what we see here is that k1 just uses the whole step xi. It starts at fxi yi, just like the Euler method. That's the k1 uses that, and then the k2 goes only halfway there, fxi plus 1/2 h, so it goes halfway there. K3 goes halfway there in the x. K4 also, or K4 actually goes all the way there. And so you can compare this to Hahn's method, where we had one that was just starting, and then the other one that was all the way there, and we put those two together to get our new estimate phi. Here we do the same thing. Here, let me, they give a nice visualization. So this is a graphic from the book of this method. And the other methods can be visualized in a similar way because each one of these is an f of some x and y. And because it's an f of some x and y, it's going to be some slope. And so this just shows that the slope k1, the first slope is based at that initial point. You can see it's based at that initial point, and it's evaluated there because that's the xi, that's the xi point right here, where we evaluate it. Okay, the next one, as I said here, so then we come up with k2. So that's this right here. That's the slope at this point is k2, and that again is evaluated at xi plus 1/2 h. See the 1/2 xi plus 1/2. That's where that's evaluated at. We use k2 again. We move from k1 halfway there. We're going along the slope of k2, and when we get there, we use that value, and we evaluate the function the f of x y to get our k3. We use the k3 to come down here all the way, but we step all the way to get our k4. All right, so once we have our k1, our k2, our k3, and our k4, we put them all together, and we come up with our phi that we use to take this slope phi, the phi that we use to take the entire step, and that becomes our step. So again, this is you can make a similar visualization for the other methods, but this is the visualization for the classical Runge-Kutta fourth order. And this is so we can go higher order Runge-Kutta methods, and I'll show you one higher, but the trade-off between the complexity to program these things and to worry about all the other problems that can come in and reducing complexity and programming effort versus the amount of accuracy you get, people usually stop at the fourth order Runge-Kutta method. So there we go again. This is fourth order Runge-Kutta.